Okay, let's look at the homework 4.2, number 3. Right? So first, we want to evaluate f of -1. So that's pretty easy, right? So plug in x equals 1. So sorry, x equals -1, right? So this is equal to 1 minus 1 to the 2/3 power. Actually, -1 to the 2/3 power, right? But since it's there's 2, so you square this first, so it's going to be +1. Then take this cube root, so we're going to be 1. So it's going to be 1 minus 1, which is 0, right? So this is 0, and which is the answer here, right? So +1 is the same way. So plug in 1. Then you have 1 minus 1 to the 2/3 power. But again, 1 to the 2/3 power is still 1, so 1 minus 1 is 0. So we got 0, right? So we got the right answer there, right? Then find all value of c between -1 and +1 such that the derivative is equal to 0. So let's take the derivative. So derivative is f prime of x, right? So derivative 1 is 0, so I'm not going to write anything down. And derivative of that is negative, sign was already there, so 2/3 in front, right? Then x to the, subtract 1 for the power, so it's -1/3, right? So this is going to be -2 over 3 times cube root of x. And we want this to be 0. Alright, so you can see that, actually, maybe before that, this might be better. So we plug in c, so we're looking for f prime of c being equal to 0. But this guy is -2 over 3 times cube root of x, but we want this guy to be 0. All right. Then unfortunately, there's no solution to this equation because no matter what x value you choose on the bottom, we cannot make the fraction equal to 0, and we have no control over the numerator. Numerator is -2, so there's nothing we can do. So this guy actually is never 0. So that's why this does not exist. Right. All right. So what happened is we thought that there should be a number, some number c, such that the derivative equal to 0 according to the Rolle's theorem, right? But if you look carefully, this function does not satisfy one of the hypotheses of a Rolle's theorem, right? So this function is actually nice and continuous. Number one, let's write it here, right? This function f is actually continuous. It's continuous on the interval from -1 to +1, right? Right, and the third condition was we already checked that the 2, I'll do a 3, f of -1 is equal to f of +1, and they turn out to be 0. We did that in the first part, right? All right, but so these two are satisfied, but if you look at the 2, right? So you can see that here's the derivative, so derivative is over here, right? right? This guy is undefined when x equals 0 because that would make the denominator 0. So note that the f prime, so this means that the f prime of 0, when x is 0, derivative is undefined. So we don't have a derivative there, right? So that means that the f is not continuous. So maybe f is not differentiable at x equals 0, right? So you can see that the second condition, maybe I should so the second condition was it has to be differentiable. Maybe I'll write it this way. On openable from -1 to 1, but this is violated because f is not differentiable at 0, right? So therefore this contradicts this one here. This does not contradict Rolle's theorem since here f prime of 0 does not exist, so f is not differentiable on that. So this is the answer. All right, that's it. I hope that this was clear.